All right, so another part of solving systems by substitution is just getting used to seeing it in different ways. All right, but if you understand the steps, it doesn't matter that, for example, this problem looks different from the last one. Okay, so first thing is, step one is we're looking for that equation that's going to be our substitution equation. Okay, and what we're looking for, what we talked about, is that isolated variable. Okay, it doesn't matter if it's x or y, just that it's isolated. Now, what might catch your eye right away on this problem is that this equation in blue has y isolated. Y equals all of this. But then so does this one in red. Y equals isolated 5x. Right, so which one should be our substitution? Well, in this case, the nice thing is it doesn't matter. You can pick either one. Let's just say, to keep it different from the other video, let's say I made this one in red the substitution, okay? Because again, y is by itself. All right, so what that means is y, whatever it turns out to be, is equal to or equivalent to whatever 5x is. So these are interchangeable. Okay, so what the process is, I do what it tells me to do. I go to the other equation that I didn't touch yet, and I'm going to swap out y and swap in 5x. So first thing I'm going to do is rewrite this with y swapped out, and I'm just going to leave a big parentheses. I'm going to do this substitution, swap out y and substitute in 5x. Now again, this is the key. This is what we're shooting for. What we've done is we've taken these two equations and combined them together so that we're down to one equation with one variable, not x and y, but just x. And this we know how to solve. Okay, in fact, I'm just going to write this. In this case, the parentheses didn't serve a purpose, so I'm going to get rid of them. Now, the first thing we don't like about this, again from chapter 1, is we've got x on both sides, so we need to get rid of one of those. I'm going to get rid of this one. So I'm going to subtract 2x from the right. What I do to one side, I do to the other. I get 3x equals 3. Solve that for x. I get x equals 1. All right, so there's half my answer right there. Again, that's x, 1, and then I still need to find y. Okay, so the way to find y is we just do this process again and we make a second substitution. So this answer right here is substitution number 2. And all we have to do is do what it tells us to do. Everywhere we see x in one of the original equations, either one of these two, we swap out x and we swap in a 1. Now again, since you can use either of the original equations, pick the one that looks easier. Now in this case, I definitely think this one in red looks easier. So what I'm going to do is I'm going to say y equals 5x, but again, I'm going to swap out x like this is telling me to do, and I'm going to substitute in what it's equal to, which is 1. And so then that's easy. Y equals 5 times 1, which is 5. So now I've got my solution to the system, 1, 5. Again, the visual equivalent of this, if I were to graph these two equations, this is where they would cross. Okay, so now let's check our answer by just taking this and seeing if it works for the original blue equation and the original red equation. So in the blue equation, y equals 2x plus 3, where x is 1, which goes right here, and y is 5. I do the math. 5 equals 2 plus 3, and 5 equals 5. So that checks out. Right there. All right, so let's do it with the original red equation. Take the red equation, y equals 5x. And again, stick in my numbers. X is 1, y is 5. That's 5 on the left. 5 times 1 is 5 on the right, so that checks out as well. And so that definitely is our solution to this system. It's where the two lines would cross, and it's also the only x-y combination that works for both of these original equations and works for the entire system.